Hi, my name is Yong. I'm going to conduct my e-presentation for my Advanced Robotics assignment. I have chosen one of the best robotic system out of the three of the review system, especially for our Malaysia education system. Right, the system that I've chosen is this teleoperation of robots using haptic feedback. So, what is haptic feedback device? The haptic device is actually referring to the use of the sense of touch to provide feedback or informations to the user. Alright, so in order to design this system, we need all of these components as shown in this BOM here. First is a 6 degree of freedom haptic device, and we only need one, and the unit price for this device is 1,500 ringgit Malaysia. And next is 7 degree of freedom robotics arm, and the price is approximately 1,000 ringgit Malaysia. And for the PC, we need two, which is master and slave. Each of them needs one PC, and each of the PC costs 500 ringgit. And we also have another two external sensor, which is force sensor and kinematic sensor. Each of sensor costs 100 ringgit. Alright, so total up, the bill of material is RM 3,800 and include all the workmanship fee, including engineering fee, hardware fee, software. We estimate that the cost is 5,000 per month. So the total cost for develop this design is quite depends on the time period of development. Alright, so this is basically an illustration for this design, and this application is basically made out of an omni haptic feedback device, which is having 6 degrees of freedom, and also a robotic arms with end effector with 7 degrees of freedoms. Okay, at the same time, there is also another external sensor attached with these robotic arms for some sensing purposes. Alright, the basic concept is actually the omni haptic feedback device will act as the master to command the slave and finally provide the interface to interact with the humans. Omni haptic device has 6 degrees of freedom, as you know, which the first 3 describe the positions of an effector, while the last 3 describe its orientation. For the master stylus, this is the stylus. The forward kinematic is implemented to describe the relationship between the joint angles of the serial links and position as well as the orientation of the end effector. And the same kinematic model apply to this slave as well, the slave robotic arms. Right, and finally, the forward kinematics is able to specify the relation between the Cartesian space and also the joint space. In order to control the slave, the position to position scheme is applied by sending the calculated joint angle of the master to the slave. So is thus realizing the control of end effectors. In other words, the joint angles of the master stylus will eventually map directly to the slave in the joint space, as shown here. They actually directly map to each other. Right. So in conclusions, the end effector of these robotic arms will actually move accordingly to master with minimum position error. Right, so this is basically the technical explanation of this system. Right, thanks.